Our planet abounds with natural resources: water, minerals, hydrocarbons. These are just a few of the treasures that lie beneath the Earth's surface. To access these reserves, drilling contractors have relied on Doosan portable power high-pressure air compressors for over 100 years. Much like the Earth, air compressors process air to create energy. This energy can be harnessed for many applications, including high-power drilling where units can produce pressures from 350 to 500 psi. Let's take a closer look. As ambient air enters the machine through the intake, a filter removes dirt and contaminants. To assure the compressor operates at peak pressure and efficiency, filters should be replaced periodically. Filtered air continues through sealed piping to an inlet valve. This valve controls the volume of air that reaches the air end and prevents oil from returning to the filter after shutdown. Next, air enters the first stage of compression, a positive displacement pump that uses two helical rotors to compress the air. When the rotor screws turn, they form a vacuum which draws air through the rotors and into a chamber where it can be measured in cubic feet or meters per minute. As air travels along the rotor flutes, the space becomes progressively smaller. Because the cavity between the rotors is larger at the inlet end and smaller at the discharge end, air becomes compressed. This process creates a significant amount of heat. During compression, oil is injected into the rotors. This serves three critical purposes. 1. To lubricate the rotors, bearings, and seals. 2. To seal the space between rotors to keep pressurized air from escaping back to the inlet. And 3. To remove excess heat so the air end can run at optimum temperatures. Using oil to maintain accurate temperatures maximizes compressor efficiency and helps control moisture. Now the air moves to the second stage of compression. A second set of helical rotors compresses the air further, and more oil is injected into the air end. The air, now mixed with oil, exits through a discharge port and is piped to a separator tank where a filter element extracts the majority of the oil and transfers it to a pressurized tank. The tank acts as both an oil reservoir and a service and fill point for maintenance. A sight gauge conveniently mounted on the tank allows operators to easily monitor oil levels. Hot oil flows out of the separator tank and through the oil temperature bypass valve. If the valve senses the oil is too hot, the oil proceeds to a cooler which lowers the temperature. The oil temperature bypass valve then mixes hot oil from the separator tank and cooled oil from the cooler, resulting in the ideal air end injection temperature. Then the oil is filtered and returned to the air end, ready to repeat the process again. Finally, the separator tank transfers air from the compressor to the service air valves, where it is ready for a wide range of applications.